Composting. How do you do it faster and better? That's what we're going to discuss today. To figure out how to do it faster and better, we really need to understand what composting is. So let's ask a basic question. What is composting? I know that you're familiar with the general process, right? You take some organic matter, you put it in a big pile, you wait, it rots down in a nice black material, and you add it to your garden. But we want to get a better understanding of this process, and to do that we have to have a closer look at what actually happens. If we look at our compost pile, the material in there is made up of a number of different compounds. In fact, thousands and thousands of different compounds. But we have these general terms that kind of describe what's in there. Things like proteins, DNA, starch, carbohydrates, fats, lignin. These are all classes of compounds. And our material is made up of all of these. And in order for composting to take place, each of these large molecules has to be broken down into smaller and smaller and smaller molecules until we end up with nutrients that plants can use. It's important to understand that this is very much a chemical process. We're taking large molecules and converting them to small molecules. Once this process is finished, then we have something that we call finished compost, that nice black material we all wish we had more of. Well, I have news for you. That finished compost isn't really finished. Now, we call it finished because when we look at it with our macro eyes, we can't see that piece of banana or that onion peel. So to us, it looks finished. But on a molecular basis, most of this material is still pretty large molecules. And there's a lot more decomposition that has to take place. And in fact, in general terms, once we have finished compost and we put that into our gardens, it slowly decomposes for about another 5 years. Now that's an approximate number that depends on climate and the type of material you started with and the kind of soil you have and so on. But as a rough gauge, consider it taking 5 years. So why does this happen? How do we go from a yellow banana peel to a black rotting banana peel to a point where we can't even see the banana peel? Well, the key to all of this are the microbes. And in fact, if we took a banana peel and sterilized it, so all the microbes were dead, and we left it sitting in a sterile environment, it wouldn't rot. There would be no decomposition taking place. Without the microbes, you simply cannot have decomposition. And the microbes do all of this chemical conversion for us. They take these large molecules and turn them into smaller and smaller molecules until the nutrients are released, and at that point, plants can make use of this material. So what happens in a compost pile? Now, as gardeners, you've probably heard the term hot composting. And that's really what we're talking about here, is a process of composting that generates a lot of heat and is fast. That is represented by this curve here. The process starts on the left-hand side in something we call the initiation phase. So we've taken all of our material, we've piled it up, we made the compost pile, and the microbes start becoming active. The fungi are the first microbes that become active here because a lot of this material is very hard to digest, and fungi are able to go after things like carbohydrates and lignins. And bacteria aren't very good at eating that. So they're just sitting on the sidelines until the fungi get going and start breaking this down. But pretty soon the bacteria get active too. And throughout the process, the bacteria are actually more important than the fungi. So they start digesting this food, and as they do that, the temperature rises. Then we enter something we call the thermophilic phase, the hot phase. And this pile heats up and it gets hotter and hotter. And the microbes are working harder and harder, and they're digesting this faster and faster. And at some point, a lot of the food has gone through an initial decomposition process, and the pile starts cooling off. The microbes become less active, the temperature drops, and we enter this maturation phase. This maturation phase is also a longer phase, and slowly the temperature drops. The amount of chemical changes is slowing down, but it's still ongoing. Now, one of the interesting things about this curve is that during the process, we use different microbes for it. So in the initial phase, we have a lot of fungi and bacteria that like cooler temperatures. But as the pile heats up, they stop working and they go into a state of hibernation. It's too hot for them, and a new type of bacteria takes over. And then it gets too hot for them, and a newer type of bacteria take over. So throughout this process, we have lots and lots of different species of bacteria active, and each one has a preferred temperature range in which they like to work. This is a very dynamic system. Lots of things going on, lots of different life forms are involved, and yet from the gardener's perspective, it's just a pile that's sitting there that's slowly getting smaller. You get some steam coming off, and slowly it turns black. But there's a lot of chemistry going on. So why does this compost pile get hot? Well, it's really no different than when you and I get hot. We are constantly respiring. What that means is that we're breathing in oxygen, we're taking sugars, we're taking the energy out of those sugars to live, and we give off CO2. And every life form does that. Microbes, animals, and even plants do this. Plants breathe in oxygen and give off CO2 24 hours a day. That's how they live. That's how they get their energy. When our activity level increases, we generate more heat. We respire more. And that process makes us hot. In a compost pile, the same thing happens. Bacteria are not that different from us humans. They're very active in breaking down these chemical materials. They're breathing in a lot of oxygen. They're breathing out CO2. The more activity there is, the hotter the pile gets. All right, so now you understand some of the basics of composting. Let's ask a different question now. How do we make compost happen faster? But before I answer that question, I'd like to ask a different question. Do you need to be fast? Do you need to make fast compost? And the answer is no. If you take organic matter and simply drop it on the ground, it will decompose. All organic matter goes through this process, but in nature, it's generally a slower process. And in fact, when I'm working in my garden, I use a really slow process. This is one of my front beds. And what I use is a method called the cut and drop method of composting. In fact, most people wouldn't even consider it composting. This is just the lazy man's way of cleaning up the garden. When I'm cleaning up things in the garden, I just drop them where they are. I don't pile them up. And the reason I do that is they will eventually decompose. Now, initially, early in spring, when I'm doing this cleanup, the garden's a little messy. You see some sticks here and there. But in no time at all of that material is hidden. And by the end of the summer, most of it is decomposed to the point where I can't see it. This method requires very little labor, and since I have a very large garden, it works perfect for me. But there are good reasons to do fast composting. You might want to make a lot of compost. The faster you make it, the more compost you can make. You may also not want to wait. I mean, this process that I'm using takes a year to make finished compost, and then another 5 years to completely decompose. If you're trying to start a new garden and you want to get going quickly, you want that compost today, not in a year from now. So you want to speed up the process. So there's nothing wrong with making fast compost. It's a good way to do it, but you don't have to. There are other options. So let's get back to this question of how do you make this fast compost? Well, it turns out that size does matter. And there's two sizes we need to consider. One is the size of the actual pile of material we have, and the other is the size of the actual particles that are going into the compost pile. So a very common way to make compost in the backyard are with these drums and these plastic bins. The problem with these is that they're simply not large enough to make hot compost. To generate that heat, we need a certain amount of mass. We need a big pile of organic matter to trap that heat in there. And if the compost containers are too small, you just don't generate that heat. So the common bins that are used in backyards don't create fast compost because they never get hot. Another very common solution are these rotary bins. And the idea here is that you put your kitchen scraps and organic material into small bins and you rotate it once a day or every couple days. This added air and this mixing speeds up composting, and the manufacturers make some pretty lofty claims. I mean, I've seen them say, hey, you can make compost in 2 weeks. Well, that simply isn't true. Remember, composting is a chemical process, and it takes time. These units are just too small to make hot compost. Now, they're great. They do make compost eventually, but they do not make fast compost. When we're looking at the size of the pile, we really need to use more of a traditional type of composting bin. And the recommended size is generally a 4 by 4 by 4 foot bin. And that works reasonably well in backyards. Now, you can certainly make them bigger than that. Bigger piles will also get hot. But unless you can get that 4 by 4 pile, you won't make hot compost, and therefore you won't make fast compost. And that can become a problem for gardeners because we don't always have enough material to fill a large bin like this. So sometimes we have to gather it up and then wait until we have enough material, or we have to bring in organic matter into the garden to make a big pile. The other aspect of size is the actual particle size of the material we're going to compost. And so a lot of people will cut up their material into smaller pieces, or they'll grind it up, or if you're using old dried leaves, they might run a lawnmower over them to chop them into smaller pieces, and that does work. But consider this. We're trying to have microbes work on this material. And to our eyes, this material looks like small pieces once it's cut up. But to a bacteria, it's still huge. Consider this. The period at the end of a printed sentence is the size of about 500,000 bacteria. They're tiny, tiny little things. And so when you think the material is small, it's still really large for a bacteria. But it is true that the smaller you make the material, the easier it is for bacteria to start digesting it because there's more surface area on each particle, and the faster the composting will take place. A really important way to speed up composting is to get the right mix to start with. And gardeners like to talk about this as the green and brown mixture. We want the right amounts of browns and greens so that composting happens quickly. So what are browns and greens? Well, browns are things that have high amount of carbon in them. Some examples are dried leaves, wood, sawdust, paper, fall yard waste that comes out of your garden, straw. These all have a high amount of carbon, and so we call them browns. The flip side of this are the greens, things like grass clippings, flowers, manure, coffee grounds, and kitchen scraps. If we look at these so-called green items, you might have noticed that some of them aren't green. For instance, manure is not green. It's actually a brown in color. Coffee grounds are also brown in color. So why are they called greens? Well, they're called greens because they have a higher amount of nitrogen. Let's have a closer look at coffee grounds. It turns out that coffee grounds have about 1.5% nitrogen. They have 34.5% carbon. So they have a lot more carbon than they have nitrogen. So when we say that these greens are high in nitrogen, that's not strictly true. When people say that, what they really mean is that the greens have a high nitrogen ratio compared to carbon. It's important to understand that this is a ratio, not an absolute number. The other thing that's important to understand is that when you're using browns and greens, you're using a very approximate way of making your compost pile. So this ratio of 3 parts brown to 1 part green is just an approximation. And in fact, if you go on the internet and try and figure out what the right ratio of browns to green are, well, it turns out people don't agree, and you'll see different numbers. The 3:1 ratio does seem to be the more popular one. Now, one of the reasons this is just an approximation is that every one of these input ingredients has a different amount of nitrogen and carbon. A more accurate way of mixing the right amounts of material is to look at the actual CN ratio, the carbon to nitrogen ratio. Now, why is this important? Why do we even care? Why does the amount of nitrogen and the amount of carbon matter? Well, if we go back to what composting is a process where microbes are digesting the material. They're doing the composting. In order for them to be really efficient, we have to provide them with food that they like. It turns out that microbes like food with a CN ratio of about 25 times more carbon than nitrogen. And when we get that ratio correct, the microbes have perfect food, they're really happy, and they digest it very quickly, and they make us quick compost. That's why this CN ratio is so important. Now, where do you get the CN ratio? Well, I do have a list of these in my book, Compost Science for Gardeners, but you can also get this list on the internet. And there's lots of places that provide these numbers. So the idea here is that you go and look at each of your input ingredients and figure out what the ratio is. So you're going to add some coffee grounds. Well, coffee grounds have a ratio of 25. Fruit waste is about 20. If you're going to put in some vegetable waste, well, that is a 15. That has more nitrogen than, say, fruit waste. But if you start putting in fall leaves are a brown. They have a lot of carbon relative to the nitrogen, and so they have a value of 50. So each input ingredient has their own CN ratio. Now, our target ratio is actually 30. Now, why would it be 30 if the ideal ratio for microbes is 25? Well, what happens in a compost pile is that as they're digesting this material, they're breathing out CO2. CO2 has carbon in it, and so that carbon gets lost to the air. So what we want to do is start with a ratio of 30, and over a bit of time, it reduces down to about 25, and the microbes are really happy. We have a really hot compost pile, and processing is going really great. By the time composting is finished, that ratio is down to about 20. So we start high, we end up low, and during most of the process, the bacteria have a ratio of 25, which is perfect for making them happy. At this point, I know some of you are saying, oh, this is getting a little complicated. Like, do I need to know the ratio of each one of these materials? Well, if you want to make really fast, efficient compost, yes, this helps. But I'm going to show you an easier way in a second. There's one other thing that makes this process complex, and that is that those lists that are published, they're all based on weight. As gardeners, we don't do things in weight. We don't have a scale in our shed to weigh out the amount of coffee grounds we have, right? We do things in volume. We add pails full of material. We add shovelfuls or wheelbarrowfuls. We don't weigh things. So here's another issue that makes this whole process of getting the right ratios more complicated. And that brings us back to this 3 parts brown and 1 part green. And so the reason gardeners use this, even though it's an approximation, it's easier for the garden to do this. When we say 3 parts brown, we're actually talking volume. So 3 shovelfuls of brown to every 1 shovelful of green. Now, it is an approximation because it depends on what actual ingredients you're putting in, but it's close enough for most gardeners, and it will give you pretty fast compost. So how important is the CN ratio? Well, the closer you can get to the ideal ratio of 30, the faster your composting will take place. The farther away you are from the ideal ratio, the slower the process and the cooler the pile. So if your goal is to make very fast compost, try your best to get close to that ratio. All right, so you've tried really hard, you've got all your ingredients, you've measured them out, you've piled them up, you've mixed them up, you've done everything right, you've got this perfect pile. and it's not working quite right. So what do we do then? Well, there are two sort of scenarios here. One is that the pile's not heating up, and a good made pile should be warm within 12-24 hours. If you don't get enough heat, almost certainly the problem is not enough nitrogen. You've got too much brown and not enough green. You don't have enough nitrogen. So the solution to that is add a little more nitrogen. Now you can do that with organic material, or you can do that simply with adding some synthetic fertilizer. The nitrogen source doesn't really matter. What's important is that we get some nitrogen into this pile. If you want to go organic, you could use blood meal or just use a synthetic fertilizer. As the nitrogen level increases, we get closer to that ideal ratio, and the composting process takes off and you'll get the heat. So what happens if you've added too much nitrogen? Well, it starts smelling like ammonia, and you'll notice it right away. That's an indication you've added too much nitrogen. What you want to do now is add more browns. Sawdust, brown leaves, straw, paper, anything like that has really high carbon levels, and it'll very quickly suck up the nitrogen and get that ratio back to where you want it to be. There are a couple other things you can do to keep that compost pile hot. One is to control the moisture level. Remember, this is a biological chemical process. Those bacteria have to live and be happy, and they all need moisture, particularly bacteria. Bacteria actually live in water. They don't live on dry material, and they're coated with a layer of water around them all the time. So the moisture level is important. Take a handful of your material and squeeze it really tightly. If you get droplets of water coming out, it's too wet. If it doesn't feel moist, it's too dry. It is important to keep that moisture level constant. Now, this can be a problem in some areas that get a lot of rain. So what people do in that area, they cover the compost pile. Use a tarp or a piece of wood or something to try and keep the rain out of the pile so it doesn't get too wet. On the other hand, in other areas like mine during July and August, when we're making a lot of this compost, it's too dry. And so we have to water it once in a while. Try to keep the moisture level correct and you'll get faster compost. How about turning it? You probably heard that you should turn your compost pile. Well, why would you do that? Well, remember what our microbes are doing here. They're breathing in oxygen, which they get from the air, and they're breathing out CO2. If we have a big pile of material and we don't have good gas exchange, we don't have good fresh air getting in there, the oxygen level drops, the CO2 level increases, and the bacteria aren't very happy. They suffocate. So it's important to keep a good air exchange to move those gases around. And that's why some people turn the pile. They'll simply go in and turn it all upside down. It's one reason people like to have two bins. So you take the first bin and you shovel it into the second bin, and at the same time you're mixing air in there. It's also why most of these compost bins have lots of holes and slits in the side. The more of those you have, the more air exchange you have. Turning becomes less important. Now, do you need to turn the pile? No. If you just pile stuff up and leave it, it will compost eventually. But that's not how you make fast compost. Fast compost does require some turning. Warmth is also important. These bacteria that we're using to make the compost want to heat up. If we keep them warm, they will become more active and they process the material faster. Now, in warm climates, that's not an issue. But in colder climates, that is a real problem, particularly if we try to make compost in winter. It just doesn't happen. So one thing you can do is wrap your pile up. Using tarps, or people use straw bales around them. Anything to trap in the heat in a cold climate will speed up that compost. Now, people love making compost. Manufacturers love selling products. So there should be no surprise that there is a compost starter. So these are products that contain either nitrogen, extra bacteria, or a combination of the two. A lot of our organic material in the fall is brown, and gardeners can have a hard time getting enough green material. So why not sell you some expensive nitrogen to put on your pile? Synthetic fertilizer works just as well and is a lot less expensive. What about the bacteria? Do you need to add bacteria? Well, you don't. Everything you put in a compost pile is coated with bacteria. Remember that period at the end of the sentence? That has 500,000 bacteria on it. Everything you put in is just covered with billions and billions and billions of bacteria. Thousands of different species in there. You do not have to add extra bacteria. For the most part, ignore these products. If you don't have enough nitrogen, you do need a nitrogen source. All right, so we've made this compost. We have finished compost. What do we do with it? The first question I guess we should ask is, when do you use it? Do you have to wait till it's completely finished? And the answer there is no, you don't really have to wait. Remember, this is a process that's going to continue on for 5 years, and we can use it any time in that process. In fact, in my cut and drop method, I use it right away. I drop it on the ground and it becomes mulch in my garden. And then I let the process go. If you take really hot compost and spread it around your garden, it's probably not good for your plants, but it'll cool down pretty quick. So you can use this material at any point in the process. Well, what most people do is they wait a couple months, 2 to 4 months, until the material is black. You can't see the original material that went into it. We now have finished compost, and that's a great material to use. If there's still some material in there that's not composted, maybe a few sticks, the walnut shells, they decompose very slowly. Some large seeds, they don't decompose very quickly either. That's okay to throw those into the garden. You don't have to worry about that material. There are really 2 ways to use this compost. One is as a mulch. So we simply add an inch or 2 everywhere in the garden. And if you do that every year, you probably never have to fertilize your garden, and you'll slowly improve the soil. It'll turn your whole garden into really good soil. That's a great thing to do. However, it's not a great mulch. Remember, this compost is very nutritious, and so it's a great place for weed seeds to germinate. So although using it as a mulch works very well, it does tend to generate a lot of weeds. Not from the compost itself, but from the weed seeds that land on the compost. Another way to use it is in a soil amendment. So you actually dig it into the soil. Now that works great in a vegetable garden, and you can very easily do that in the spring as you're preparing your beds. You simply add the compost and mix it in the soil. It also works well when you're planting things. You can add a little bit into the potting hole and mix it into the soil. It's much harder to use it as an amendment in an existing bed because you don't want to disturb plant roots. So even in a vegetable garden where you have asparagus growing, for instance, you don't want to dig that into the roots around the asparagus plants because they're permanently growing there. So in a case like that, just put it down as a mulch and keep an eye on the weeds. Can you add too much compost? And the answer to that is yes. And in fact, this is becoming a real problem, particularly with raised beds. So people are putting in artificial soil in these raised beds, or they're starting with a lot of compost. Then they add more compost to that. Those beds actually get to a point where the nutrient level is so high, it becomes toxic to plants. And the nutrient that is the biggest problem is phosphate. The reason is that phosphate doesn't move through the soil profile very quickly. So it accumulates in that raised bed. And the more compost you put in, the more phosphate you add, and suddenly nothing grows well. As a general rule, an inch or 2 of compost everywhere on your soil will not cause you a problem. If you use more than that, like a 6-inch layer, when you're making a new bed, that's usually okay too. But once you've made the bed, don't add more than an inch or 2 of compost each year. How do you make better compost? And in fact, is one type of compost better than another type? For example, if you're going to the store to buy composted manure, around here, I generally have 3 choices. I can buy cow, horse, or sheep. Well, the bottom line is that they're pretty much the same. It turns out sheep has slightly higher nutrient levels, but other than that, they're the same. So most compost is the same. It doesn't matter where it comes from. But there are some things we should talk about to make sure that we're really making good, safe compost. The first one is diseases. I see a lot of comments online that say don't take your diseased leaves and compost them because you don't want to spread that disease. Powdery mildew is an example. Well, I have news for you. In the fall, almost everything in your garden has diseases. They're covered in fungal spores. Bacterial diseases are affecting those leaves. Those are all those little spots you're seeing. If you're only going to compost things that have no disease organisms on them, you're not going to have much material to compost. The other thing to think about is that when your leaf shows mildew, for instance, those mildew spores have come in on the winds, and they're everywhere. They're on the soil, and your walkway, on your grass. They're sitting everywhere. You're not going to keep them out of your garden by eliminating those leaves and throwing them in the garbage instead of the compost pile. You might as well compost all this material. That's what nature does. Now, some of the diseases will come back next year. You probably have powdery mildew every year. But that's not because you composted those leaves. It's because it flies around in the air, and next year it's flying all over your community and it lands on your plants again. For the most part, compost everything. There are a few exceptions. If I had a plant that I knew had a virus on it, I wouldn't compost that. Throw it in the garbage and get rid of it. There are one or two very nasty diseases that spread really easily to plants. You might want to keep those out of your compost pile. But for the most part, if you haven't identified a problem, don't worry about those leaves that have spots on them. Compost it all. Here's another problem you have to watch out for if you're going to use straw or hay, either in the garden or in the compost pile. So there are some herbicides called the plant growth regulator herbicides. The problem with these herbicides is that they're long lasting. So the farmer sprays it on his field to get rid of the weeds, to grow some straw or hay. It's now on the straw or hay that's collected from the field. If you use that in your compost pile, it's also in the compost pile. If that straw or hay is used to feed animals, it actually travels through the stomach of the animal. It doesn't get digested, so it comes out in their manure. So now animal manure also has these herbicides in them. So you go out and get some manure to add to your compost pile, you bring it home, you compost it. At the end of the process, those herbicides are still in the finished compost. If you spread that around your garden, it will harm your plants. You have to be very careful you don't get these on your property because they last for a couple of years in the soil. And it doesn't take a lot of these chemicals in the soil to harm plants. So if you're using hay or straw or manure, make sure you're getting it from a reliable source. Now, this isn't a huge problem, but every year there are some cases around the country where people have added this material to their garden and ended up damaging their plants. So you need to be aware of it. What about toxic plants? Should you be putting those into your garden? And I can think of two examples that are discussed a lot by gardeners. The first one is rhubarb leaves. People think that rhubarb leaves are very toxic because of the oxalic acid in them. Well, it turns out that's a complete myth. The amount of oxalic acid in leaves and stalks are the same. We eat the stalks. We could eat the leaves. If you don't eat the leaves, and most people don't, you can certainly throw them in your compost pile. They won't do any harm. Another one that comes up a lot in discussions is monkshood. Okay, so monkshood is quite toxic to humans, and it's probably best not to compost it. But I'm going to guess in most cases you don't have a big pile of monkshood leaves, so it's not really an issue. A few stalks in your compost pile that gets mixed in with a lot of other things is not going to cause a problem in your garden. I don't know of any plant that has toxins in it that will harm plants after you compost. So I think you can take all the plants in your garden and put them in your compost pile. Plastics are also a problem. If you're getting municipal compost, a lot of that has bits of plastic in it. Right? People use plastics to gather up their yard waste, then they send it to the municipality for composting. They try to take most of that out, but there's always little bits that come back. And the plastic itself won't really harm anything in your garden, even if you use it for vegetables, but you really don't want that in there. Another concern is microplastics. So a microplastic is a tiny, tiny piece of plastic. Really the same as the big piece of plastic, except it's now so small we really can't see it with our eyes. And we're finding microplastics everywhere. If you're using plastic in the garden, sheet plastic for keeping the weeds down, weed barrier, plastic bottles, any kind of plastic you use in the garden is slowly decomposing and giving off microplastic. Now, we don't know how harmful these are. We are finding them everywhere. I'm pretty sure they're going to cause us some sort of problem, but we don't know what that is yet. So it's best to try to avoid microplastics, which means avoid plastics in the garden. There's also a category of plastics called compostable plastics. Many types of tea bags are actually made out of plastic, and the manufacturers even recommend that they're compostable, and they are. The problem is that the definition of compostable plastic means that you're composting it for a long period of time at really high temperatures in special facilities. There are very few of those facilities in North America. So in most composting facilities, they are not able to compost compostable plastic. Your compost pile will not compost compostable plastic. So keep those out of the compost pile. Another issue are weed seeds. Are you afraid of putting weeds into your compost pile because you'll spread weed seeds around? Well, it certainly will happen. Weed seeds are killed by higher temperature. If you make a hot composting pile, that will get rid of most seeds. It also gets rid of a lot of pathogens. Now, I know a lot of you won't get a really hot compost pile. You might get a warm pile or even just a cold pile. So are seeds a problem there? I don't think they really are. I mean, don't go out of your way to collect weed seeds and put them in your pile. It's much better to pick those weeds before they go to seed. But if there are weeds in your gardens that have gone to seed, those seeds are now everywhere. The fact that you take the rest of the weed and compost it isn't going to increase the amount of weed seeds around, because your weed seeds have already floated throughout your garden. They've covered your soil everywhere. Adding some compost isn't going to make a lot of difference. Personally, I try to keep weeds from going to seed, but if I'm pulling weeds, I'll compost those. I don't think there's a problem with those. Now you know how to make fast, perfect compost, but there are a few other topics I'd like to discuss. Now, there are many other aspects of composting that you might be interested in. And so I put a list of resources together. And if you go to this link, you'll find all those resources. It's gardenmyths.com/composting. That's a special page that will give you a whole list of resources that will add more information to the whole process of composting. Let's talk about some composting methods that are not composting method. The first one is vermicomposting. That's a very popular way to get rid of kitchen scraps, and the process works really well. But it turns out that the material the worms produce, that vermicompost, those worm castings, that's not composted material. What the worms really do is they grind that organic material into very small pieces. Once the pieces are really small, then composting takes place. And people who do vermicomposting usually leave that material in the bin for a couple months, and then they harvest it and they age it for another couple months. That's when the composting is actually taking place. It happens outside of the worm. Bokashi composting is another process that's starting to catch on, and it has some merit. It's something you can do in the kitchen. You don't have to go outside. It's a great process for smaller quantities of material. Great in the wintertime when you don't want to go outside in the snow to throw out your kitchen scraps. So it's something worth looking into. But you have to understand that bokashi is not composting. It's a fermentation process. At the end of the process, we haven't started decomposing that material yet. The orange still looks like an orange. When you're finished bokashi, then you have to find some way to compost it. And one thing you can do with the material is throw it on your compost pile. Here's another so-called composting method. And these are these new electronic composters that you keep in the kitchen, and you put in your kitchen scraps and it turns into the compost in 24 hours. None of these produce compost. What they do is they dry the material, they grind it up a little bit, so they produce dried kitchen scraps. Now, this is great material for the compost pile, but they don't make compost. There's also a lot of controversy about some materials that you could compost. We'll go through a list of these. The first one is meat. Should you put meat into a compost pile? Well, the reality is that meat composts just fine. It composts slower than other things. It has lots of nitrogen in it, so it will compost. Now, some people don't like to put meat in their compost pile because it attracts rodents. The rats and mice, they come to eat it. Well, so what? They poop in the pile and they add a little extra nitrogen. That's okay. It's not likely you're going to attract all the rats in the neighborhood to your compost pile. How about bones? Well, bones also attract rodents, but bones really don't decompose, not quickly. They will eventually decompose, but it takes a long, long time. So there's nothing wrong with throwing them in the pile, but they don't really add anything. Rose clippings is one thing I don't put in the compost pile. Wood, twigs, anything like that decompose very slowly, and those thorns on the roses are still in there in the finished compost. And I just hate getting stuck by those as I'm working with compost. So all my rose clippings get thrown away in the garbage. What about cheese and oil? Well, you can throw those in too. It probably attracts some rodents as well. It will decompose, but slowly. So I wouldn't put a lot of that material in there, but a little bit, that's fine. You have an old salad that has a little oil on it, that's fine. Throw it in your compost pile, don't worry about it. What about pet waste? A lot of people recommend not composting pet waste. And in fact, all the medical government organizations say that. Don't do it because you could be transmitting diseases. Well, I have news for you. If you have a cat or dog, you are already exposed to whatever diseases that cat or dog has. If you compost their poop, it won't make any difference because you're already exposed. Now, what about going around the neighborhood collecting other pet poop? Well, that may not be such a great idea because you could catch a disease from that. But provided you don't put it on the vegetable garden, you could even compost that. I think our concerns about pet waste are exaggerated. What happens to compost in the garden? What does it end up becoming? Now, some of it gets decomposed and the nutrients come out, but the traditional view of this is that eventually it creates humus. So what we have is that we start with organic matter, right? We put that in our compost pile, it decomposes, it gets broken into smaller pieces, smaller molecules. We put that into our garden and that process continues. The molecules get smaller and smaller and smaller, and eventually it turns into humus. Now, humus has been described as these massive molecules. The interesting thing is that no one has ever been able to come up with an explanation of why molecules get smaller and smaller throughout this whole process and then end up huge. The other interesting thing is that we've studied humus for 200 years, and no scientist has yet been able to isolate it and characterize it, understand what the chemical structure is. We have very vague descriptions. Now, we've been able to do that with everything else, including complex proteins and complex DNA molecules. And scientists can work with almost any molecule and tell you what the structure is, but this humus, they can't. Well, there's a new view of this, and that is that humus doesn't actually exist. Now, I don't have time to go into the whole story here. You can read about it on my blog, gardenmist.com. But humus doesn't exist. It's created in the lab when we try to extract it from soil. The modern view of humus is this, that we start with organic matter. That gets broken down by microbes into smaller and smaller molecules. And once those molecules are smaller, both microbes and plants use those molecules, and they use them to build up large molecules again. And that creates organic matter. So we have this cyclical process. Organic matter decomposes into small molecules. Plants, microbes, insects, dewworms, everything that's living in the soil then takes those small molecules, uses them to live and to grow, and in the process builds up large molecules, which becomes organic matter. A better way to think of humus is that all of this material that's in soil is humus. I'd like to look at one other aspect of composting, which is becoming more prominent these days. Is composting bad for the environment? Now, your original reaction might be, well, no, I mean, we're making good soil, we're growing food, all of this is great for the environment. Well, you have to take a step back. What happens during compost? These microbes are respiring, right? They're taking in oxygen and they're producing CO2. Every time we compost something, we produce CO2. And as you know, CO2 contributes to global warming. So the whole process of composting produces CO2 and global warming. That's not good for the environment. But you have to have a closer look at this. What happens to the leaf that falls in the forest? There's no gardeners around to compost. It just falls and nature takes over. Well, it composts. It decomposes. Some of that leaf will turn into CO2. But some of that leaf also turns into organic matter in the soil. So some of the carbon is sequestered in the soil, and some of it ends up as CO2. That's just how nature works, and it has always worked that way, even before humans came along. So the fact that compost makes some CO2 isn't a great story, but we have to remember that the material that's left, the finished compost, we put into the soil, and that sequesters carbon in the soil, which is actually good for the environment. The other way to look at this is that you have to look at alternatives. You have a pile of leaves. If we don't compost, what are you going to do? Well, we can put them in the garbage and they can go to the city dump. Well, it turns out that that's a worse scenario, because at the city dump, it gets covered with material. We exclude the oxygen the microbes need to compost properly, and a different group of microbes takes over, and they create methane instead of CO2. It turns out that methane is much worse for global warming than CO2. So the worst thing we can do is take our organic matter and send it to the city dump. We're better off composting it. Another gas that can be produced in composting is nitrous oxide. When the amount of nitrogen in the compost pile is too high, the excess nitrogen is given off as nitrous oxide. And nitrous oxide is also really bad for global warming. That's why it's important to keep the nitrogen level low enough so we get composting, but not so high that we smell the ammonia. The bottom line is that composting is going to happen whether we get involved or not. Composting organic material and keeping that organic material on our properties is the best thing we can do for the environment. Yes, it produces some CO2, but we also sequester CO2 into the soil, and that's good for the environment. All of the other options for this organic matter are worse than composting. If you want to connect directly with me, you can do it through a number of means. I have a YouTube channel that's called Garden Fundamentals. It has almost 500 gardening videos on it now. We have a Facebook group that's also called Garden Fundamentals. You're welcome to come and join there. I'm on there every day, and you can ask me anything about gardening. And we have lots of experts there to make sure that you get the right answers in gardening. And we've started a podcast called Garden Fundamentals. I also have a number of gardening books available. My passion is writing about garden myths, and I have the blog called gardenmyths.com. You're welcome to go there. That has over 700 different blog posts, and all of them contain myths. But if you like to read it in book format, I've created 2 books, Garden Myths, Book 1 and Book 2. And both of these are self-published, so the best place to get those are on Amazon. My newest book is called Food Science for Gardeners. Now, I don't have it yet, but it is available for pre-order at both Amazon and my publisher, and it should be available and start shipping in September. So I'm really looking forward to this book. The focus of this book is not about growing food. It's about growing nutritious food. What is nutritious food? How do we grow safe food, both from a bacterial and a chemical perspective? How do we preserve food so we preserve those nutrients that we've got in our food? And of course, there is a chapter on growing food. My other books include Soil Science for Gardeners, Microbe Science for Gardeners, Plant Science for Gardeners, Compost Science for Gardeners, and one of my first books is called Building Natural Ponds. The pond book shows you how to build a pond without pumps, electricity, or chemicals. Basically, you dig a hole and put in the right amount of plants, and you have a pond that takes very little care. The Plant Science for Gardeners was recently awarded the Independent Publishers Book Award, Silver Medal Award for Science. I think it's really important you understand the basics of how plants work. Once you understand that, a lot of the other things we do in the garden will make so much more sense, and you'll be able to weed out the myths from the truths. All of these books are available from Amazon, but I've arranged a special discount with my publisher, New Society. If you go to the link called gardenmyths.com/Pavlis25, that link will take you directly to my publisher. And if you use the code Pavlis25, you'll get a 25% discount on all of my books that are published through this publisher. Unfortunately, it doesn't include the Garden Myths books because those are published through Amazon. Now, this is an affiliate link, and I will get a small commission if you order from the publisher, but it won't cost you any more. Thank you very much for supporting my efforts, and I look forward to answering your gardening questions in the Facebook group. Happy gardening.